Good morning. Hope you're ready to go. Well, it's probably evening where you are, but it's morning where I am. Welcome to Kojo's Pre-Algebra, and today we're going to be talking about solving addition and subtraction equations. And before we get started, got a little coffee break here this morning. I know that many of you already know how to do a lot of equations, but I want to make sure that you understand the mathematical reasons behind it. So we're going to discuss that today, and the equations that you're going to see are going to be fairly simple. So keeping that in mind, you're looking for what I expect from how I want you to show your work. We're going to discuss verbal models, labels, and algebraic equations with word problems, and what the expectations are there. And then we're going to talk about the properties associated with solving equations. Now, the properties that we're going to talk about today are not on the quiz that is coming up on 2.1 through 2.4. Those properties, though, will be covered on the Chapter 2 test, which may be the end of next week, but I'll give you plenty of notice for that. So let's get started. So we're going to start out with the subtraction equation. X minus 27 equals 30. And the whole idea is when we want to solve an equation, and we start off with simple ones so that you know the answer, so that when you do the problem, you know what the answer is. So if you do the work the way I expect you to, and then you don't get the answer, then you know that you've made a mistake somewhere in the work. Okay, so I wanted to get the red pen as well as the blue pen. When we look at an equation, and the equations will get much more complicated as we move forward, fairly quickly too, I want you to know. We look to see what's being done to the variable. Well, what is being done to the variable here? We're subtracting 27 from the variable. We're subtracting 27 to the variable. So in order to solve the variable, even though we already know the answer is 57, we still have to show the work and the process, because it's not about the answer this year, it's about the process and showing your work. So if we're subtracting 27, how do we manipulate the equation to isolate x? Because whenever we solve an equation, that's our goal, is to isolate the x on one side and have a coefficient of positive 1. Very important to remember that. Our goal when we solve an equation is to isolate the variable and make sure it has a coefficient of positive 1. So we look at that to manipulate the equation, and we're going to show our work vertically. I don't like to see horizontal work, and I don't like you to take and say, oh, it's 57, so it's 57 minus 27 equals 30. No, you have to show me the work. So when we do this, if we're subtracting 27, we use what we call inverse operations to undo what's being done to the variable, not opposite. We don't say, well, I'm subtracting 27, so the opposite, I do the opposite, which is to add 27. No! Opposite has nothing to do with isolating a variable. Opposite is associated with the number line, and it's in relationship to absolute value and a number's position in relation to 0. So if I have 5, the opposite of 5 on the other side of the number line is negative 5. So the word opposite in math is associated with the number line, not with equations. Very important. So we always use inverse operations to solve for equations. So if we're subtracting 27, the inverse operation is to add 27. Whatever we do to one side of the equation, we must also do to the other side of the equation, so we keep the equation equal. Let me say that again. Whatever we do to one side of the equation, we must also do to the other side of the equation to keep the equation equal or balanced. So, what separates the equation into two sides? The equal sign. We have the left side and the right side. So if we add 27 here, we're going to have to add 27 here. Yes, you must show this. And just look how I'm doing it vertically. So when we do this, we have to show that these two cancel. We're going to bring down our x. No, you do not have to show arrows. I'm showing that for the matter of explanation. And then we come over here and we go 30 plus 27. You must put plus 27, not just 27. You must show that. That's important later. So we get x equals 57. We do a quick mental check and say, oh, 57 minus 27 is indeed 30. So what did you gather from this? You have to show your verb vertically. We talked about keeping the equation, both sides of the equation, equal, or keeping the equation true to itself by manipulation of the variable in the equation. And we must show vertical work. We talked about inverse operations versus opposite and how that's not used. Now that we've done that, we need to talk about what's the mathematical reasoning that allows us to manipulate the equation. As I've told you, you can't just say, well, we're going to add 27 to both sides because that way we can find out what x equals. No, there's always a mathematical reason. And that leads us into two properties when we're solving addition and subtraction equations only. So, here's the two properties. The addition property of equality. These are used to solve equations. Addition property of equality and the subtraction property of equality. Here, what's being done to the variable? We're adding 20. That's right. So in order to solve it, what's the inverse operation of adding 20? Subtracting 20 from both sides. Yes, you have to draw the line. And what property is that? That's the subtraction property of equality, because if we're adding to the variable, to manipulate it, to undo that, we must subtract from both sides. What allows us to subtract from both sides? The subtraction property of equality. That allows us to subtract 20 from 20 and 20 from 81. So we're going to get m equals 61. And then we get m equals 61. Either way is right. Then what we're doing over here is, what are we doing to the x? Yes, we're subtracting 15 from the x. Subtracting 15 from the x. So to manipulate it and to isolate the variable, we must take the 15 to the other side. Notice, I don't want it done horizontally. I don't want you to rewrite it and go x minus 15 plus 15 equals 40 plus 15. No! I want to see it vertically underneath. And there's a reason for that. There is a reason for that, and I expect you to do it because later you will understand it. That light will go bingo and you'll understand why. So, what do we have to do? We have to add 15 so that we can get x isolated, because x plus any number, x plus 0 is the number itself. Any number plus 0 is the number itself. And then we're going to say plus 15, x equals 55. What property is that? Well, what are we doing to manipulate the equation? We're adding 15. So it's the addition property of equality. So whatever you actually do, whatever inverse operation you do to manipulate the equation, to isolate the variable, is the property that you use. You need to know those for the chapter test. Okay, now we're going to go over the other properties, and these properties are going to help you with expressions and also equations as we move forward. And you need to know these for the test, the chapter test, not the quiz coming up. So you have the commutative property of addition, which we've already talked about. It's where you have two terms, where you have a plus b equals b plus a. Doesn't matter which order I add them. If you think like 15 plus 100, now we know we might say, oh, it's 115. But if you were younger, you might have been it would have been more easy for you if you put the 100 first and said, well, 15 plus 100, oh, 100 plus 15 is 115. You're using the commutative property of addition up here. The commutative property of multiplication, that's also two terms, separate when you're multiplying. Now, if we looked at this, this is considered one term, right? But when we're looking at properties of multiplication, this is considered two numbers that we're multiplying together. So like if I had 2 times 3, it's the same thing as saying 3 times 2. If I had x times 5, it's the same thing as saying 5x. So now you see how you can manipulate. Now we have the reason why we can flip the coefficient. Remember I told you x 5? We talked about this in class and you guys go, well, why? Some of you said, why can't you just leave it like that? And I said, well, there's a reason, but basically it's because you don't see it written that way. Well, this is why we're allowed to change it. So now you're starting to see that we have mathematical reasons for everything we do. There has to be a mathematical basis to allow you to do this. So it becomes 5x because of the commutative property of multiplication. The associative property of addition is when we're just grouping numbers that we're adding, and it's 3 or more, and we go a plus, the quantity of b plus c is the same thing as a plus b plus c. So it's just grouping them differently. And that's where I kind of confused you last time, and I apologize for that. The associative property of multiplication is the same thing. If we have 3 numbers that we're multiplying, it doesn't matter what order we pick to multiply, we're still going to get the same answer. So a times bc or ab times c. So we'll play around with those in class. After the quiz, I have some property worksheets and stuff like that we'll do probably, maybe Wednesday night for homework or Thursday. Now the most important thing we need to talk about today that some students struggle with is how to solve word problems, and there's a whole thing that you have to do with my expectations. This will lead you to success later as we get into more difficult word problems. Word problems I'm going to give you this week, very easy. You're going to know the answer. You're going to say, why do I have to do this? Because you're practicing the process. You are practicing the process. I don't care about the answer. Well, I care about the answer, but I care about the process more. So you're going to learn right now about labels, verbal models, and algebraic equations. Labels in a word problem identify the important parts of the word problem, the important numbers. It tells you what the numbers represent, and you have to identify that in words. So you'll rewrite the numbers and you'll associate what they stand for. Verbal model is using the labels that you've created to write the equation without the algebra. So you're writing a verbal description of the equation, but it's a verbal model because you're plugging it into an equation form, as you'll see in a second. And the algebraic equation is what you need in order to solve the equation. So you write that. But the easiest thing to do sometimes, well, the first thing you do is you always write the labels, you identify the important numbers. Some students then like to write the algebraic equation so that you kind of get it set up. And then they go up and they plug in the verbal model. So let's see what happens. I want you to pause the video and I want you to write this word problem down. It's easy. You know the answer, but remember, easy is not, the answer is not the focus. So, Arjun is baking a cake. The recipe calls for 10 eggs. He has already put in 7 eggs. How many eggs does he need to add? No, Mrs. Cohen, I already know the answer. It's 3 eggs. Well, of course you do. I know the answer. But the directions are going to tell you, when you see this, write labels, a verbal model, an algebraic equation, and solve. And you must show your work. So we're going to start off with labels. It's a good idea to start coming up with a strategy as the word problems become more difficult to help you identify what's important in the word problem. So the first one, it says that it calls for 10 eggs. So that's a total. So 10 eggs equals 10 eggs needed for cake. And you might put total eggs needed for cake. 10 is the eggs needed for the cake. 7 is how many eggs I've already added. Okay? 7 is how many eggs I've already added. And then what's x? We have to identify a variable. We don't write the answer. Even if we know the answer, we say, what is x? The label doesn't tell us the answer. The label identifies what the x is. It's always the question. Eggs needed. Now I'm going to write the algebraic equation right now. You can never have an equation equal x. That is not an equation. I can't say 10 minus 7 equals x. No, that is not an equation. All you have to do is go 10 minus 7 equals 3. No, I want you to do something where the variable has to be manipulated. So, I could do a couple of different things. I can say 10 minus x equals 7, or I can say, no, not 10 minus x. Yeah, 10 minus x equals 7, or I can say x plus 7 equals 10. I'm going to say x plus 7 equals 10. Now that's the algebraic equation. What's the verbal model? The verbal model takes the labels and plugs them in place of the variable and the numbers in the algebraic equation in equation form. So what's x? Eggs needed. And I like to write it like this because it kind of keeps it, instead of, if I wrote eggs needed plus how many eggs I've already added, it'll go on run on. But if I put it short and sweet, so I go plus because I'm plugging it into the equation, 7 is eggs I've added. You can kind of make it a smaller little thing. Equals, because a verbal model is written just like the equation, total eggs needed. That is your verbal model. There are no numbers. That is your verbal model. And then you would solve the equation by coming up here. So I would probably write the verbal model over here or above it. I mean, I don't have enough room to really show my work. I always want the labels somewhere nice and vertical. And then you could identify the verbal model here and then put the algebraic equation here and then solve it. So you would subtract 7 from both sides vertically and then say x equals 3. But if you put x equals 3, you're going to lose a half a point because you did not identify the units. Anytime you have a word problem, you have to identify what it is. So you would say x equals 3 eggs needed. Okay. I want you to write down 2 things you've learned and 1 thing you still have a question about. And bring that into class tomorrow and we'll get started. Have a great evening and I'll see you tomorrow. Bye-bye.